Hello viewers, welcome to my channel. Today we shall be looking at the topic trigonometry. The aspect of trigonometry we'll be focusing on is the complementary angles. We'll be discussing this in relation to trigonometric equations. As you can see on the board, we have two notable formulas in trigonometry, which is cos theta equal to sine bracket 90 minus theta, and also sine theta equal to cos bracket 90 minus theta. These are the equations that signifies the complementary angles in trigonometry. We'll make use of it to solve some problems on trigonometric equations. Now, I will have to get you familiar with some concepts which you must be familiar with, and that is the concept of SOHCAHTOA. 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 Then we'll have to interpret this. But before we do that, let's quickly explain what a complementary angle is about. What is a complementary angle or complementary angles? Complementary angles are these two angles that add up to 90 degrees. For example, if I asked, what is the complement of 60 degrees? The complement of 60 degrees is 30 degrees. Why do I say so? Because when you say 60 plus 30, that will give us 90 degrees. So the two angles that add up together to produce 90 degrees is known as complementary angles. Let me ask again, what is the complement of 40 degrees? The complement of 40 degrees is 50 degrees. Because when you say 40 plus 15, that will give us 90 degrees. So the two angles that add up to 90 degrees is known as complementary angles. I hope that is quite clear. All right, so let's move further. In a right angle triangle, as you can see on the board, this particular corner here is known as right angle. It is because of this box here that we call this triangle right angled triangle, because it contains a right angle. And we know that right angle is equal to 90 degrees. This symbol here represents 90 degrees. And remember also that the sum of the interior angles of any triangle is equal to 180 degrees. And you know quite well that 90 plus 90 will give us what? 180 degrees. So if this one is 90 degrees, that is to say the two angles that we have here remaining will be complementary to each other, because they must be 92. Because this one is 90, then this plus this must also be what? 90 degrees. I hope you are getting the concept. All right, so now I want to introduce an angle inside this particular diagram. Okay, so assuming I have theta here, the opposite of theta here, the place that the theta is facing or the angle is facing is called opposite. Then the other side of it is called adjacent. Then the longest side that is facing the right angle is called the hypotenuse. I hope this one is quite clear. All right, so now to get to know what this place will be is another thing we have to look at. Can you suggest what should be here? I have here as 90 degrees. Then I have here as theta. What do you think I should be having here? Let me give you a simpler example. Assuming this is a right angle triangle, and we know that this is 90 degrees. If, for example, I have 50 degrees here, can we obtain the value of the angle here? And if we can, how do we go about it? Remember that the sum of the interior angles of any triangle is equal to 180 degrees. So I have 90 here. That is to say that the remaining ones will be 90. Okay, so to get this particular place, I will have to say 90 minus 50, which will now give us 40. So what will be here will be 90 minus 50 will give us the value of the angle here. I hope you are getting it very clearly. All right, so now let's get it down here. So I have 90 degrees here. This is a theta. What should this place be? This place will of course be 90 minus theta. I hope it's understandable. Good. Now that we've gotten the contents of this particular right angle triangle, now let's explain this concept of SOHCAHTOA. SOHCAHTOA. So means sine theta, opposite over hypotenuse. Cos theta, adjacent over hypotenuse. Tan theta, opposite over adjacent. That is the concept that we are very much familiar with in trigonometry. Now, I want us to get this formula. What we should be doing now is to solve this with respect to sine and cos theta and sine theta. So when we will be referring to theta as a single angle here, we'll have it as theta. When we say what is sine theta, we should be able to know that sine theta is opposite over hypotenuse. And what is the opposite of this theta here? The opposite of this theta here is here. So I will label it with some important letters. Let's say we have C here, we have A here, and we have B here. All right, to identify the sides of this triangle. All right, so following the concept of SOHCAHTOA, I want us to get the simple, formulas of this sine of theta and cos of theta. Can we do that? And sine of this theta means that we have to get the opposite of the theta, which is opposite over what? Hypotenuse, which is what? The C. So how do we get to do that? So I can say that sine theta, that's this theta now. The opposite of this theta is A. Sine theta, which is what? Opposite. And the opposite is A over hypotenuse. The hypotenuse is C. Let's call this one my number 1 equation. So let's get the cos of this as well. Cos theta. Cos theta. What is the cos talking about? Cos says adjacent over hypotenuse. What is the adjacent of theta here? The adjacent of the theta here is B. That's the adjacent. Adjacent over hypotenuse. That means B over C. Let me call it my equation number 2. All right, so going by this one, we are done with using theta. Now let's use this other angle, which is 90 minus theta, and get the sine of this and also the cos of this. Our aim here is to establish this formula for you to get to know how this formula come about. We shall be using it to solve some problems on trigonometric equations. Now let's guess with this one. That will be sine of 90 minus theta. This time around, we are using this to represent our angle. And when we talk about sine, what comes to mind is opposite over hypotenuse. So what is the opposite of this angle here? The opposite is B. Okay, so I will simply say B over hypotenuse, which is what? C. Call it my equation number 3. Then let's move to the other one. That is the cos of this. Cos 90 minus theta. Cos we know as adjacent over hypotenuse. What is the adjacent of this angle here? Of course, the adjacent, this is opposite. So the adjacent will be A. So that will be A adjacent, which is adjacent over hypotenuse. That's A over C. Let's call it equation number 4. Now that we've gotten this, what we are going to do is to do comparison of the single sine of theta and that of sine of theta, cos of theta, sine of 90 minus theta, and cos of 90 minus theta. Let's do the comparison of the two and to see the ones that are giving us the same result. If you look at it carefully, you find out that we have A over C here, and we equally have A over C here. That is to say that this and this are equal. This and this are equal. So how do we establish that? That is to say, I can say that this sine theta is equal to cos theta I mean, that's cos bracket 90 minus theta, that these two are the same because they produced the same result. So I can simply say that sine theta, which gave us this, which is the same as this, is the same as this cos bracket 90 minus theta. And that is exactly what we have here. Then again, I can compare this and this. Both of them are the same. They produced the same result. So from there, I can say that cos theta is equal to this. That is exactly what I have here. I hope the formulas are quite clear. That's how I come about this particular trigonometric formulas of complementary angles. All right, so let's make use of this in solving some problems. Here we are required to solve some problems regarding trigonometric equations. As you can see on the board, number one, you have a sine bracket x plus 20 equal to cos bracket x minus 10 degree. Then number two, sine bracket 90 minus 5 theta equal to cos bracket 180 minus theta. Then number three, you have cos bracket x plus, that's a alpha, is equal to sine bracket x minus alpha. Then again, number four, you have a sine 3a equal to cos bracket a minus 26 degree. So these are some of the equations that we should be tackling now. Then you pay attention as we solve them in relation to the formula that we just proved. All right, just pay attention to the following solutions. For number one question, we have sine bracket x plus 20 equal to cos bracket x minus 10. Recall the formula that we introduced earlier on regarding complementary angles. We have cos theta as being equal to sine bracket 90 minus theta. Then again, we also have the other formula, which is sine theta equal to cos bracket 90 minus theta. These are the two equations that will be helping us to resolve this problem that we have. Now, what we have to do here, as you can see, we have different trig representations. Here we have sine, here we have cos here. So all we need to do is to change one of these, either to change cos to become sine, or to change sine to become cos, so that what we'll be having here will be same thing. All right, so looking at it from this, whichever way you approach it, that will give you a perfect answer. Now, let me start with this particular one. To change this particular one to what? Sine. Remember, when you have cos theta, you want to change it to sine. That will now be 90 minus the theta given. And what represents our theta here is the entire thing inside this bracket. The entire thing inside this bracket represents our theta, just like this theta here represent the theta. So for me to solve this, to change this particular one to sine, all I will do is to say 90 minus everything I have here. That will make it to look like sine. Okay? All right, because I want to change it to sine. All right, so look at what we're going to do. The next step will be sine x plus 20 is equal to sine. I'm changing this to sine now. All right, so taking the whole of this as being theta here. So changing it to sine will not mean I will have to say 90 minus the theta that I have here, which represents all of this. So that will not be 90 minus everything that I have here, which is x minus 10. That is the step that we have taken now. So the next step will now be, we do away with the sign. When you do away with the sign, you now solve it algebraically. So that will give us x plus 20 is equal to 90 minus times x gives us minus x. Minus times minus will give us plus 10. All right, so to collect like terms, so we have x here. The minus x coming over here become plus x equal to 90 plus 10 will give us 100. Then 20 coming over here become minus 20. So we have it as 2x is equal to 80. All right, so divide both sides by the coefficient. That will give us x is equal to 80 divided by 2. The answer is 40 degrees. So that is the value of x for question number 1. I hope this is quite clear. All right, so let's take example 2. Number 2, we can change any one of these trig representations here. Either we change cos to sine so that both will be the same signs, or we change sine to be cos. So let's transform this one to be cos. All right, so you know what it means, that you are having sine here, you want to change it to cos. That will now be 90 minus everything that you have here. 90 minus everything you have here, because the whole of this represents this theta here. All right, so to get it, that will now be 90 minus that theta that you have, which is everything that we have in this bracket. If we want to change this one, we change it to sine, and changing it to sine means that 90 minus the whole of this will equally give us, they both, whichever step you take, will give you the same answer. All right, so let's transform this one to be sine. As you can see, that will be cos. We change this one to cos rather. That will be 90 minus the whole of this representing the theta. 90 minus 5 theta. 5 theta. All right, equal to cos 180 minus theta. All right, so we do away with the cos. So what we now have is 90 minus 90. We open the bracket, minus times minus becomes plus 5 theta equal to 180 minus theta. Minus theta. All right, so this we cancel out. We now have 5 theta is equal to 180 minus theta. So collecting right hand, we have it as 5 theta, then plus theta equal to 180. So this will give us 6 theta is equal to 180. So dividing both sides by the coefficients of theta, here we have it as theta is now equal to 180 divided by 6. With the value of theta will be 30 degrees. So that is the solution to number 2. Let's quickly move to number 3. Then for the number 3 question, here we have cos bracket x plus alpha is equal to sine bracket x minus alpha. All right, so we still follow the same approach. We can transform this to be cos. That will give us cos x plus alpha is equal to cos. Remember, when we introduce another trig representation, it will now be 90 minus everything that is inside the bracket. So that will now be 90 minus x minus alpha. All right, so we do away with the cos here. So we have x plus alpha is equal to 90 minus x, then minus times minus is plus, then that's alpha. So collecting right term here, we have x, then minus x coming over here become plus x. We already have alpha here, then plus alpha coming over here become negative alpha equal to 90. So by virtue of collection of like term, this one will cancel out. That becomes 0. X plus x will give us 2x equal to 90 degrees. So we divide both sides by the coefficients of x. That will be 90 all over 2. The value of x is 45 degrees. That is the solution to the value of x. For the number 4 example, which is the last, so we can transform these to cos. All right, so both of them will be cos. All right, that would then be cos. This is representing theta now. That will be 90 minus 3a. All right, then equal to cos a minus 26. All right, so we have to do away with the cos, then go with the numbers that we have here, which is a minus 26. So collection of like term here, we have 90 minus 26 coming over here become plus 26 equal to A. The minus 3A coming over here become plus 3A. So that will give us A plus 3A will give us 4A is equal to this plus this will give us 116. So we divide both sides by the coefficients of A, which is 4. 116 divided by 4. Of course, the value of A is 29 degrees. So these are the solutions to these trigonometric equations that we just presented. Please don't forget to click on the subscribe button for you to be able to see other interesting videos as they come in this channel. Thank you and have a blessed day.